Hello, in this video we continue discussing factoring. Today we talk about trinomials and some special binomials. Let's get started. Recall that factoring was the process of rewriting polynomials as a product of its factors. So instead of a polynomial with 5 terms, maybe after factoring out a GCF, we got it down to 4 terms, and then we did factor by grouping, got it down to 3 terms, and then maybe we've solved a trinomial, and okay, you get the idea. We continue to factor until we can no longer factor. It turns out, we're going to see in our future math classes like pre-calculus, you're going to realize that any polynomial can be factored until the point where your factors are either linear, like x plus 5 raised to the first power, or irreducible quadratic, like x squared plus 9. And you're going to learn more about that in the future. That's how you know you're done, when they're all linear or they can't be factored any further as quadratics. So let's get started with reminding ourselves what we talked about last time. In our last video on factoring, which you might need to go back and watch again, we said that the very first thing we always do is look for a GCF. We always look for a GCF. If possible, by factoring that out, we are going to have much nicer numbers to work with and maybe even fewer terms. Once we know how many terms are left, if it's 2 terms, then we ask ourselves, is it a special binomial, like a difference of squares? Which means we're going to have something squared minus something squared. An example of that might be x squared minus 9, right? If you have a difference of 2 squares, you need to think, well, that's really x squared minus 3 squared. 2 things are being squared and they're being subtracted. That's the word difference. So a difference of 2 squares will always be able to be factored as the first item not squared plus the second item not squared, a plus b, times the first item not squared minus the second item not squared. That's a minus b. So in this case, applying that format, we would get x plus 3 times x minus 3. And you don't have to take my word for it, you can prove it, right? Once again, take that half a second to distribute and watch what happens. X times x is x squared. That's our first term. X times negative 3 is negative 3x. 3 times x is positive 3x. A negative 3x and a positive 3x wipe each other out and they're gone. No more x terms. But the 3 times the negative 3 is the 9. The negative 9, I should be more clear, the negative 9. And that is the original difference of 2 squares. So anytime you have a difference of 2 items that are squared, and you might not recognize them as squares, but 9 was a perfect square, something times itself, which gives you the original number, you can do that. Now, a difference of cubes or a sum of cubes are also special binomials that we'll be on the lookout for. So instead of x squared minus 9, maybe we have x cubed minus 27, right? Because 3 to the 3rd power is 27. Same idea, you're going to say what was being squared goes first, so like x minus 3, and then square each item, like x squared and 3 squared, which is 9, and then multiply the items together. So like x times 3 is 3x, and you put that here. We'll practice it. It sounds a little crazy right now. The sum of cubes works exactly the same way, but the only thing different is the signs in the middle. So you'll notice that both of these formulas are identical except for the signs in the middle. They have to be opposite there so that the middle terms do cancel. All right, so we're going to focus on those special binomials in this video. We're also going to focus on the trinomials. Today we're going to learn how to factor a trinomial. If we have a leading coefficient of 1, it's really easy. That's usually a guess and check method. You're going to see what I mean in a moment. Or if we have a coefficient of something other than 1 in front, we're probably going to use the AC method. But both educated guess and check and AC method are fair game. And finally, the grouping method we did in our last video, so feel free to go back and watch. That applies when we have 4 or more terms. So let's dive into our first example. So we notice here that we have a trinomial. Now, if I have a trinomial, 3 terms, the educated guess and check method, which is typically called trial and error, but some textbooks like educated guess and check, okay? So the educated guess and check method, the idea here is to think about what the factors of the constant number here would be. So if you have the example x squared plus 2x minus 8, the constant number is negative 8 in our example, right? So you ask yourself, what factors of that number would, when added up, produce the middle term? So here's what we're saying. We notice that 8 could be rewritten as 1 times 8, if I just look at the positive version. Or it could also be written as the factors of 2 times 4, right? Those are a couple of ways that we could write 8, okay? So what I notice is, because I have a negative 8, the signs must be different, right? If you multiply two numbers with different signs, we'll get a negative result of -8. So maybe I have a +1 and a -8 or vice versa, or a -2 and a +4 or vice versa. But here's how we pick which one to use. We want to pick the pair where if I were to add them up with different signs, their sum would give me the b term, so 2x in this case. So what I need to do is, you can see in the box here, what times what gives me c, but then when I also add them up gives me b. Okay, you're looking for products of c which add up to b. So if you want to write that out in words, you're looking for products of c which add up to b. It kind of rhymes. You can go to sleep chanting that. Right? All right, so what products of c add up to b? Those are going to be the two numbers that you need to fill in these boxes here. So we're looking for what times what gives me c, but when added up would give me b. Okay, so you notice that because 2 and 4 are 2 apart, if they had different signs, we would have a difference of 2, whether positive or negative, depending on how we write it. Now, since we wanted to end up with +2, we would make the bigger number 4 positive. Notice that? And we would make the smaller number 2 negative. Okay? And then we can check ourselves. That's why it's educated guess and check. Let's check. If I were to distribute the x, we get x squared, so that's my first term. If I distribute the x again, I get -2x, and if I distribute the 4, I get +4x. Well, -2x plus 4x is +2x. That is my second term. And 4 times -2 is my -8. So I know that I'm right. Now, I might have gone way too fast for some of you, and if you don't have your multiplication tables down really fast and you're really good at them, you might want to work on that. Go back to that first slide where I have that link in the notes, and you can find a nice list of apps on your smartphones and websites that can help you improve your multiplication speed so that you don't have to be struggling with the calculator here, because that can take a lot of time. Now, once you've found the pair that works, when multiplied together and their sum produces the number 2b, what products of c add up to b, now you have factored the trinomial into something times something, a binomial, a linear binomial, times another linear binomial. Okay, believe it or not, that's the easiest way that these present themselves. They get a lot harder when your leading coefficient here, when x squared has a number in front that's not 1, right? If it was a 2 or higher, this is going to present a little bit more work for us to do. So our guessing will take on a little bit more effort, okay? Our educated guessing. Otherwise, the AC method, which I think most students prefer, will be the way to go. So that's what I wrote in the bottom here of your notes. Note that if A is not 1, this method can take more time, and you might want to abandon the method and try another one called the AC method. So let's see if we can practice this method with a couple examples. In example 1A, it says factor, if possible, x squared plus 7x minus 30. So here, once again, we have the same example as before, so see if you can pause the video and try to mimic what we did. A lot of learning math looks like mimicking at first, unfortunately, until we start to understand what's going on. So go ahead and see if you can mimic what I did in the first example. Pause the video and come back and see how you did. All right, so I looked first for a GCF. I didn't see any. There's no number that all three items share in common. But if they did, if they shared a number or a letter or both, we would pull that out first, wouldn't we? Okay. The second thing I noticed is I have a trinomial. It's really good practice when learning something to write down what you're doing and why, so that you can leave a record for yourself when you go to review. So I noticed this is a trinomial, and when it's trinomial, I can either do the guess and check method, the trial and error method, or I can try something called the AC method, which we'll learn about in a couple slides. So with the educated guess and check method, we said we're looking for factors of C which add up to B. So let's look at C. It's -30, which means to get a -30, they're going to need different signs. Now, I didn't have to write the negative. I just wanted to remind you that we're going to need different signs to get a -30. Okay, so let's talk about just 30 for a moment. 30 could be 1 and 30. What else? 2 and 15. Yep, if you got that, that's true. How about 3 and 10? Some people forget about that one. 4, does 4 go into 30? Not so much. How about 5? Yeah, 5 times 6. 7, not so much. 8, no, not so much. 9, no. 10, well, we're back to here, 3 times 10. So we've looked at all of them now. So our job now is to say what factors of C add up to B, noticing that they must have different signs because you're ending up with a -30. So when you subtract them, do we get 7? So which of these are 7 apart? Well, that's kind of clear now. 3 and 10 are 7 apart, aren't they? So I would need to be using a +3 and a -10, or a -3 and a +10? Well, if we want to add up to a positive, the bigger number should be positive. So the bigger number must be positive to end up with a positive answer. So we use a -3 with a positive 10. So what did we do with those? Again, you can look back at the previous slide if you forgot. We opened up our two binomial parentheses for each, and we said, well, we need x times x to get x squared when we distribute or FOIL. And now we have our two numbers to insert. We can put -3 here, and we could put positive 10 here. The order that you put your multiplication doesn't matter, right? 3 times 2 is 2 times 3. It's called the commutative property of multiplication. Addition has the same property, by the way. So we noticed that we could write x minus 3 times x plus 10 or x plus 10 times x minus 3. Now again, before you declare your victory, you look for two things. One, can I go any further? In other words, are there any other special binomials or GCFs that we need to take care of? Maybe you forgot the GCF the first time and there's still like a 2 in common. Then you need to take that out at this point. But there are no GCFs because we looked at the beginning. Second thing, are there any special products that are left, right? Well, we have linear factors here, don't we? Degree 1, x minus 3, x raised to the first power, it's linear. X plus 10, degree 1, it's linear. If you have linear factors, those are done. You can't factor them any further. It's only if they're raised to a higher power like 2 or 3 or 4 where we have to ask ourselves if we could go further. The third thing you can do here after you've asked yourself a couple questions is check, right? Does this give me the original? Yeah, x times x is x squared. X times 10 is 10x. You can keep that in your head, right? 10x. -3 times x is -3x. So what is 10x minus 3x? Positive 7x. We got it. And -3 times 10 is the -30. We know we're right. If you remember from the last video at the very end, we said that this graph basically represents a parabolic trajectory. And if we were to set it equal to 0, we'd be finding x-intercepts. So technically, if you were to go further, if this was equal to 0, let's say, setting x minus 3 equals 0 would mean x would have to be 3, because that would make this factor 0, wouldn't it? What would make this second factor 0? If x equaled -10, right? So it turns out that 3 and -10 are the two places where it zeroes out the equation, which makes those your x-intercepts. So if you were talking about the parabolic trajectory, that's how you're going to be finding those x-intercepts, by first factoring and setting it equal to 0. So this is step 1 in a more complex problem. Okay, but for now, it just said factor, you've done it, you checked it, you're golden. Now in B, it looks almost identical, except we have a coefficient of x squared that is 2, not 1. So we mentioned before, when those coefficients get bigger than 1 or they're different than 1, we're going to have a little more work to do in the guess and check method. The AC method is lovely. It loves numbers that are other than 1, and I'll show you why in a minute, because that's A of A, B, and C, that's our A. Okay, so the guess and check method said you would normally open up your two parentheses like we did here in the last example, and you would normally just write x times x, right? But now that I have a 2x squared, what times what gives me 2, not just 1 x squared? Well, yeah, you're going to need a 2x and an x. Now, we're kind of in luck because 2 is still a prime number. That means the only factors it has is 2 in itself. Sorry, 1 in itself, I should say, which is 2 times 1, 1 in itself. So it's a prime number, which means the only possibilities are 2x and x, like there are no others. But imagine with me if that was a 6x squared. Yeah, you could have a 6x and an x, that's one option. What's another option? You got it, 2x and 3x. So the bigger those numbers are, the more composite they are, meaning they have lots of different factors possible, the more possibilities to guess and check, guess and check, guess and check. And that's why a lot of students do not like this method when they have to do a lot of mental math or a lot of writing out the math or using their calculator a lot. They would prefer a nice strategic approach. And the AC method, which we're going to look at in a moment, would be that nice strategic approach. But if you wanted to do the guess and check method, if you have really good multiplication skills, this would be the way to go. So you'd put 2x here and x here. Then you would still do the process like we did originally. We look for factors of 6. Well, 6 could either be 1 and 6 or 2 and 3. Now, normally we said which of those factors adds up to 7. But now that we have this 2 in front of x squared, that's going to play a role in our foiling, isn't it? So it's not that we're necessarily in and of themselves going to have to add up to 7. But the whole process should produce 7x. So let's try a couple of them. Let's try maybe 1 and 6. We're lucky because all the signs are positive, so this is clearly the same sign and both positive, right? So positive and positive. So let's say I put a 1 here and I put a 6 here. Let's see how it works. So here comes the checking part. We guess and now we check. Well, that's 2x squared, which is what we wanted. This would be 12x, wouldn't it? Plus 1x. Well, what is 12x plus 1x? Uh-oh, that's 13x, isn't it? That is not what we wanted here, so that's a fail. We did not get 7x. So you can see how the guess and check method can take time. So let's try another pairing. Well, what else could we have done? We had the 2x here and the x here. How about we switch the order of 1 and 6? So you maybe put 6 here and 1 here. Would that have benefited us? Let's take a look. 2x squared, check. 2x times 1 is 2x, and 6 times x is 6x. What's 2x plus 6x? We're closer. That's 8x, but we wanted 7x. Oh no, we failed again. Now this isn't really failure, so I'm being a little facetious here. This is it's failure in the sense that these aren't the correct pairings, but you have done nothing wrong. This is just the process of the educated guess and check, okay? You have to check, see if it works. If not, keep going. Let's continue. What if instead of 6 and 1, we chose the other grouping of 2 and 3? Let's give it a whirl. So now I try, maybe I put my 2 here, maybe I put my 3 here. And again, we could switch the order if we need to. So let's take a look. 2x squared checks out. How about 2x times 3? That's 6x. And 2 times x? That's 2x. What's 6x plus 2x? Oh no, we're back to 8x. Okay, you're probably frustrated with me by now. Professor, why is this taking so long? This is just the beginning. I promise math takes a lot of time, but when you actually find the right answer and it solves a real problem, you're going to feel great about yourself. So you have to go through the hard work to get the benefits. So let's continue, plugging away. 2x here, x here. What's the last way we could have written this? Well, yeah, we could have put the 3 here and the 2 here. Now, maybe you got lucky the first time, or you did a little math in your head so you didn't have to write as much down. Totally good, okay? Take a look at what would have happened. 2x squared checks out. 2x times 2 is 4x. 3 times x is 3x. 4x plus 3x is our magical 7x. We finally nailed it. And the 3 times 2, of course, is the 6. We built it that way, okay? We finally found the factorization which is correct. And again, you can know you're right because we just FOILed it out. So you know that it means the same thing as the original trinomial. Okay, so as you can tell, the guess and check method took us 4 attempts this time to get to it. It could have been the first attempt and you got lucky, right? Or you thought about it and you wrote down the right one the first time. That's fine, okay? But notice that if that 2 had been a number that was bigger, like if it was a 4 or a 6 or a 12 or a 24, you would have a lot more possibilities to check. So keep that in mind. That's why I'm going to recommend to most students the AC method. You do need to be able to do both, but recognizing which method is faster makes you more efficient and saves you time. So you're going to want to be able to recognize what you're better at and what you can do in a more efficient manner. Let's take a look at that method. The AC method says if you were to consider the trinomial as ax squared, where a is your coefficient of x squared, plus bx, where b is your coefficient of x, plus c, where c is just the constant, that means no variable there. If you consider that your setup, then the idea for the AC method is taking a look at that same problem that we just did that took us 4 different tries. If we notice that the trinomial 2x squared plus 7x plus 6 has a coefficient other than 1 in front, so it's 2, we could begin by multiplying a times c. So we're going to first basically say, get a times c, which is what we're doing right here. A times c would be the number 2 times the number 6. So what is 2 times 6? It's 12. So what do we do with that number? The trick that we're trying to basically do here is we're trying to take a trinomial and make it a quadnomial, or a polynomial with 4 terms. I got too excited for my mouth to catch up with my brain. Yeah, so we're going to try to split the middle term. 7x could actually be written as maybe 2x and 5x, right? Or 3x and 4x, or 1x and 6x. There's lots of ways to write 7x. But if we could split it up in a very sophisticated way that is going to make our lives easier, we're going to do that. And so this is a little cheat that people have discovered a long time ago. And so we're going to learn from them. What they found was that if you asked yourself, what factors of a times c add up to b? It's kind of like what we said earlier. What factors of c add up to b? Yeah, it's very similar. But this time we incorporate the a. What factors of a times c add up to b? Well, for a times c we got 12. And the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Those are the only ones I can think of. I don't think I missed any. 5 doesn't go in, and we've already talked about 6. Okay. So now we ask ourselves, what factors of 12, and it's positive, so the sign should stay the same, and we're trying to end up with a positive 7, so they're all positive. What factors of 12 add up to 7? So which of those would it be? You got it, 3 and 4. So we can now say that we're going to split 7x into two terms, 3x and 4x. That means the same thing, doesn't it? You haven't changed anything. You're just choosing to write it as 4 terms to make your life easier. You might not feel like it's easier, but I promise it's going to be lovely. Get ready for it. Okay, so you've split the baby, if you will. You've split 7x. You've split bx. That means you now have a polynomial with 4 terms. If you go back to our last video, we learned something called the grouping method, which said that you could factor a polynomial, as long as it's not prime, if it had 4 or more terms by first grouping or pairing up 2 terms together and another 2 terms together. Which grouping do you recommend? Yeah, I probably would do the same. You could do the first 2, but notice that 2 and that 3 are kind of ugly together. Most humans that I've seen doing a problem like this will choose the first and the third because those 2's look really nice together, 2x squared and 4x, and they probably pick the second and the fourth because the 3's in common, right? You don't have to. You could have done the first 2 and the last 2. Totally your call. Okay, so once you group them up, you factored out what they had in common for each pair. 2x is what we share in our first pair, so we pull that in front. What would that leave me with? That's right, just x plus 2. If you need to go back and watch the other video, this would be a great point to pause. Otherwise, what we're doing probably doesn't make a lot of sense to you. Okay, let's take a look at the next pair. 3x plus 6. What did they share in common? You got it, just a 3. And what would be the binomial that they're next to, that the 3's next to? Just x plus 2, wouldn't it? Okay, so if we take a look and we see that we have an x plus 2 in common, what did we do next? We pulled it in front as our GCF. Well done. And the next parentheses, the next linear factor should be their coefficients, 2x plus 3. Now, you can know you're right a couple of ways. One, you could go back to the last slide because we just did this problem with the educated guess and check method, the trial and error method. It's the same thing, isn't it? You could also know it just by looking at this answer. You could FOIL, couldn't you? 2x squared, 3x plus 4x is 7x, and there's my 6. Yep, this is definitely the correct factorization, and this would produce 2x intercepts eventually of -2 and -1.5, or -3/2. We'll learn about that going forward. Okay, so the AC method, a great way to factor a trinomial when your leading coefficient A is not 1. Notice it can get big. If that number was like a 12 times a 6, that's going to be a lot of different ones to check, different combinations. So usually we try not to give you numbers that are too crazy for a test purpose, but in real life, these numbers can be pretty massive. So you would need to take some time to find those pairs. Okay, let's have you practice the AC method in our next slide. Example 2 says factor if possible. In part A, we have 3x squared plus 11x minus 14. So to begin, we could say, well, I noticed that I have a trinomial where the leading coefficient is a 3. So one option, the educated guess and check option, that's probably like option 1 if you're writing your notes in order here. Option 1 could be open those parentheses right away, right? And if you open those parentheses right away, what are the only ways to get 3x squared when you multiply 2 terms together? Yep, it's prime number 3, so just 3x and x, kind of like 2x squared was. Then you could say, what factors of -14, different signs, do we have? Well, we have 1 and 14, so we have 1 and 14, and we have 2 and 7. And you could try all of the groupings until you find the group that works. They should have different signs, and you should end up getting a positive 11x when you add your terms together. Okay, so let's say, for example, you chose the first one. So I chose maybe a 1 and a 14 here. Okay, what about my signs? I could make one positive and one negative because I have to end up with a -14, right? So let's say you did a positive 1 and a -14. Let's see how that would work for us. Well, if we did it that way, we'd get 3x squared, which is correct. But notice here we're getting a pretty big number, 3 times 14. That's a -42, okay? And then a positive 1x. -42x plus 1x is -41x. Uh-oh, that doesn't look like positive 11x. So this is incorrect. But what if we did it a little different, right? What if instead we had 3x here, x here, but we swapped the numbers? Would that help? Maybe we put the 14 here and the 1 here. Let's check our signs. Let's do perhaps a positive here and a negative here. We could switch them if we need to. Well, now we get our 3x squared. We get our negative 3x. So far, so good, a little smaller. And we get our positive 14x. Ooh, that's nice. 14x minus 3x. What is that? It's positive 11x. Hey, isn't that what we wanted in the middle? It is. And then we get our negative 14. So this time, it didn't take me too long because I used the first grouping and I just switched the order and I kept the signs in the right place by chance, by coincidence, or by a gut feeling, if you will, okay? But that could have taken 4 to 8 attempts before you stumbled upon it. So what was our second option? Yeah, that's right. Our second scenario here was the AC approach. The AC method said multiply your A times your C first. So A times C, in this case, is 3 times negative 14. Well, that would give us negative 42. And then we'd have to look for factors of AC which add up to B. So you could think of, well, how do you get 42 with different signs? Keep in mind they are going to be different. You could do 1 and 42. You could do 2 and 21. Yeah. Does 3 go in? Yeah, 3 goes in. So 3 goes into 4 one time, remainder of 1, and 3 goes into 12 4 times. Hey, there's the 3 times 14 that we knew about. Now we could keep trying to find other ones. For example, you could see, does 4 go in? Does 5 go in? Does 6 go in? Does 7 go in? Etc. You can keep going, but you only need to go as far as you need to, right? So we're looking for a sum of different signs, because it's a negative, right? Different signs that produces a sum. When I combine different signs of these numbers together, do I produce the middle term 11, positive 11? And I can see right now that 3 and 14 are the way to go, can't I? Okay, so that means that I can split my middle term into a 3x and a 14x, but which one should be positive and which one should be negative if I want to end up with a positive 11x? Good job. I would need a positive 14x. So I'm going to use the positive 14 and I'm going to use the negative 3. So with this AC grouping method now, we would rewrite the original. Let's come on down here, right through my head there. We're going to come on down here and we're going to notice that we have 3x squared. But instead of 11x, we're going to write minus 3x, positive 14x, oops, there's a 1, 14x minus 14. If you can't read that, that second term is positive 14x. Okay, so now we group them together 2 by 2 and see what happens. I'll do the first 2 and the last 2 because they're pretty self-evident that they go together well. What is the GCF of 3x squared and negative 3x? Just 3x. Leaving me with what? Yeah, just x minus 1. Good job. What is the GCF of positive 14x and negative 14? Good, positive 14. Leaving me with x minus 1. Coincidence? I think not. So what do we really have here? Factor out the shared binomial x minus 1 and we'll have our answer. X minus 1 is one factor and 3x plus 14 is our other factor. That sounds and looks familiar if you just scroll up to right above it. When we did the method of educated guess and check, we got exactly the same 2 factors, which will produce the exact same x-intercepts if this is about a quadratic functions graph. Okay, so we did this one together. I'd like for you to try example 2 on your own, keeping in mind always look out for the GCF first. So try example 2b on your own and then come back and see how you did. Okay. So let's say you decided you're going to do educated guess or check, or maybe you're going to do the AC method. What's the first thing you did? You found the GCF. Great job. That makes your life a lot easier because this time there's a 4 in common, isn't there? There is a 4 in common. So we would have w squared in parentheses plus 5w plus 4. If I was in class right now, I'd see a lot of people erasing because a lot of people forgot the 4. Okay, if you didn't factor that out, it's not the end of the world. You can still get there, but you're going to have much bigger numbers to worry about. If you did the AC method, for example, you'd have to do A times C first. 4 times 16 is 64, and list all of those factors. It's a lot easier to work with smaller numbers, and that's why the GCF first will save you pain and suffering later. All right, so the next thing I noticed was that I have a trinomial. And if I have a trinomial, I either try the educated guess and check, which is number 1 of the last part of the problem, or I try the AC method. Now this time, the educated guess and check sounds pretty nice here, doesn't it? Because we only have a 1 as our coefficient of w squared. By the way, we often switch out the variables from x to w's or v's. Don't let that throw you. You can use x if you like to on your paper. Just keep in mind that at the end you have to write your answer with a w. Okay, so let's see what this would look like. Well, we could keep the 4 in front. You can't just delete it. It's still there. But now we'd open up our two binomials. I'm doing this according to approach 1, educated guess and check. So we'd say what times what gives me w squared? Well, just w times w. And then we play the same game that we did earlier today in this video. We said what factors of c add up to b. Now technically that's exactly what the AC method does, isn't it? What factors of AC add up to b? Because here a is just 1, isn't it? So it's the same thing, it just looks a little different. Well, 4 has a couple of options. You could do 4 times 1 or 2 times 2. Now we're ending up with a positive 4, so should I use the same sign or different signs? The same sign, and they could both be positive or negative, but if I want to end up adding and getting a positive, they must both be positive. So w plus something, w plus something. Which of those pairs would add up to 5? You're right, 4 and 1. So maybe you put a 4 here and maybe you put a 1 here. Again, the order in which you place the factors doesn't matter because multiplication is commutative. Order doesn't matter. Finally, it looks like we have linear factors only, so this would be our final answer. 4 was our GCF in front. W plus 4 and w plus 1 are the other two linear factors. You can know you're right by FOILing it out, w squared. We get w plus 4w, which is 5w, and we get 4, which is what we had right here. Then redistribute the 4, and you're back to where you started. So you can know you are right. And again, this would actually produce 2 x-intercepts on a graph. The 4 itself would not produce an x-intercept, but would affect how fast it's growing. All right, let's take a look at our next slide where we put all of this together with our binomials. Remember we talked earlier about the difference of squares, the sum of cubes, and the difference of cubes? So this is all pattern recognition. After you look for a GCF, if you see a binomial that fits one of these 3 patterns, you are expected to factor further. So we did one earlier, x squared minus 9. You can look back at the first slide or rewind the video. Rewind, goodness, you could go back in the video. You could also notice something like this, x cubed plus 27, right? That's really something cubed plus something cubed. Or you can notice maybe something like a cubed minus, let's say, 64. That's 4 to the 3rd power, right? So that's a difference of 2 cubes. But all you would need to do in each case is ask yourself, what is being squared or what is being cubed? Those are the numbers that go in the first parenthesis here, okay? Then you ask yourself, okay, now that I have, so we'll just do this one for example, it would be x plus 3, because 3 is being cubed to get 27. Then I would say, now I need to square each of those numbers. So x gets squared, 3 gets squared. What's that? It's 9. Good job. Similarly, for the difference of 2 cubes here, we had a getting cubed and 4 getting cubed because 4 cubed is 64, and we keep it minus. Then we open up our second trinomial parentheses, and we would put our squared items, a squared. What's 4 squared? That's right, 16, positive. Now what do we put in the middle? Here I'm going to use a different color to hopefully draw your attention. In the middle, we notice we take the opposite of whatever sign we had, right? So if this is a negative, it's a positive. If it was a positive, it's a negative. So what we're going to notice here is we need to put a negative, and here we need to put a positive, a times b. So if you were to take the items that were being cubed and multiply them together, that's a times b. So here it would be x times 3, which is 3x, and here it would be a times 4, which would be 4a, okay? Now here's where it's really cool. If you take the time to actually distribute x to each of these or a to each of these and then the other number to each of them, you'll notice that because of the sign difference that we just built in there, you're going to watch a lot of terms cancel, right? The only terms which will remain are those last 2 cubed terms, and that's where we started. So it turns out that anytime you have a difference or a sum of cubes or a difference of squares, as we did with x squared minus 9, you are able to factor further, and you'll be expected to. Now I did ask a question at the bottom of the slide. I said, can you imagine what would happen if you had a sum of squares, like x squared plus 9? Would that ever be able to be factored the same way? Well, if you put an x and a 3 and a 3, and tried changing the signs, both positive, both negative, different signs, if you had different signs, you'd end up with the negative 9, which is what we had here. But if you had the same sign, both positive, you'd end up with a positive 6x, and both negative would end up with a negative 6x. So how do you cancel it out? It turns out this cannot be factored unless you're thinking of imaginary numbers. So if I had 3i and negative 3i, which we'll learn about in coming days, then I could factor it. But over the real number system, we say it's prime. It cannot be factored. So for your purposes in this course, a sum of squares is prime. In future courses with imaginary numbers possible, then yes, we'll be able to deal with it. But for you, a sum of squares is prime over the real numbers. All right, let's get to our practice example. Here we go. Clearing and go. Factor example 3, if possible, 81x squared minus 25. Do we recognize a special pattern, or is there a GCF I need to take care of first? No, there's no GCF, but if there was, I always do that first to make my life easier, right? There's nothing they share in common. But I notice that this is a difference of two squares. So it's pattern recognition. A lot of math comes down to recognizing a pattern so that you know what to do next, what model applies. So the model that applies here for a difference of two squares was, what's being squared here? Well, that's a 9, and that's an x. When I square a 9x times a 9x, I get 81x squared. And what's being squared for 25? Just 5, right? Because 5 times 5 is 25. So the pattern holds that a difference of two squares, I open my two binomials, and I say what was being squared? 9x, 9x, 5, 5. Those are what we end up with at the ends, right? To get our 81x squared and our 25. But in order for the middle terms to cancel, we have to have opposite signs for each of the second terms. So like a positive and a negative. It doesn't matter which order you put those in, as long as they're both present. If we had the same sign, you can try it, you're going to end up with another term in the middle, right? So the same sign would produce a middle term, but the different signs cancel out. Okay, so try that on your own. Check by foiling. You should notice that the middle terms do in fact cancel. Now for your last example, I encourage you to pause it. Feel free to look at your slides, the previous slide, to try to recognize the pattern and come back and see how you did. Okay, did you recognize a pattern? First, there is no GCF again. No GCF here again. But there is a pattern. It's a difference of cubes, a difference of cubes. So the x cubed was my clue that I was saying, can I take 125 and think of it as something times itself 3 times? Well, yeah, that is 5 to the third power. You could check your calculator if you don't believe me. It's true. And 8 is really something to the third power. Do you know what it is? It's a perfect cube. It's called 2x. Yep. So 2x to the third power would give you 8x cubed. So now could you practice with me what that pattern was? You open a binomial times a trinomial. And in the binomial, you say what was being cubed? 2x and negative 5. So you keep the sign the way it is here. Notice where that sign becomes opposite in the formula? Right in the middle. That's where it becomes the opposite sign. So those have to be opposite for the right things to cancel, for the pattern to work. And then what happens? Well, we continue. We square them. So this is where we write our squares. Square what? Well, we're squaring the items that you originally had here and here. What was originally being raised to the third power? Your a and your b, if you will. So if you take 2x and you raise it to the second power, what do you get? You get 4x squared, don't you? What if you take negative 5 and you raise it to the second power? What do you get? Yeah, that's right. You get positive 25. Now, what went in the middle was the product of the two. So right here is where we put our product of the two items here and here. What is their product? So 2x times 5 is 10x, but we make it positive so that the right things will cancel. And you can double check and triple check until you feel comfortable with that formula. Usually it takes at least 3 times in a row getting something right before you feel like you've mastered that skill. So make sure you can check yourself, feel comfortable, and then practice a few times in your homework to get these really, really quickly and correctly. Okay, so it will be important to recognize these patterns: difference of squares, difference of cubes, sum of cubes. Finally, we put all this together so that eventually we'll be able to find x-intercepts of graphs. Back to that zero product rule is our last slide together. Here we go. All right, you survived. Whenever we have a polynomial and we're trying to find x-intercepts, we're trying to solve this equation, we noticed that if it was a linear equation, we could just get x by itself, right? But if it's not linear, if it's degree 2 or higher, which is what we have in the quadratic equation we're looking at, the degree 2 equation we're looking at, we need to get 0 by itself. So how do we get 0 on one side? We can move negative 6 to the other side. We'd have x squared plus 7x plus 6, and you add it to both sides, equals 0. Now we ask ourselves, what kind of polynomial do I have and can it factor? Right? This is a trinomial, which means we could try the educated guess and check method, which I think is easy to do in this case. Or you could do the AC method, a times c, what factors of that add up to b? But this time it's just 6. What factors of 6 add up to 7? Yep, just 1 and 6, and they're both positive because everything's staying positive. So you can have x plus 1 and x plus 6 as your two factors. double check. X squared, 6x, 1x is 7x, and there's my 1 times 6, which is 6. Okay. Once you have factor times a factor equals 0, it only works if it's equal to 0, right? The zero product rule applied. If you look back at our last video, we ended with that as well. Set each factor equal to 0, you'd get x would either equal -1, so that could be 1 x-intercept. So on a graph, for example, if this is -1, that could be 1 x-intercept. And x plus 6 equals 0 would mean that x would equal -6. So that potentially could be another x-intercept when we get to our graphs of parabolas, quadratic functions, which mean degree 2 polynomials in the future. So eventually, when we get to our quadratic section, we're going to learn that those are the x-intercepts. Ooh, that's ugly. Those are the x-intercepts for a parabola opening up. We're going to learn about that coming soon. So these have a meaning that right now you don't fully understand. And that's okay. Learning is all about, it's like if you're going to the gym, you're trying to work out muscles and things are going to start to hurt. They're hurting as they're stretching them out. They're using muscles you haven't used before. That's okay. This is going to seem painful at first, but eventually when you start to see the results of how all of those skills work together to be able to solve really cool problems, you're going to feel really proud of yourself. All right, so go practice because math is not a spectator sport, and I'll see you next time.